Okay. Then here you have the index, which indicates what we are going to talk about. In the next slide, before we begin, I'm going to explain who we are. We are a group of 5 students from Universidad Juan Carlos from Madrid, Spain. We are here to explain our presentation about URJC aircraft, which is a suborbital and hypersonic aircraft. I hope you enjoy it. Next slide.
For the development of the aircraft, we have to study other supersonic aircraft that have been developed through the history. The wings we choose are based on the wings that the Concorde had. They were modified so that when the aircraft exceeded the speed of Mach 1, its center of mass will not be so affected and did not move so far back. In the right image, we can see the overture from Boom Technology, a model concept of the Concorde. Next slide. Our aircraft must reach 100 kilometers in height, known as the Kármán line. The aircraft will have 2 engines similar to the engines of the Lockheed SR-71 Blackbird and a rocket engines to reach those 100 kilometers above sea level, as the North American XB-15 did. Next slide. The sum of all of these aircraft and more have resulted in next slide, the ARIC J-72. And now I leave you with my partner Alicia, who will explain the flight plan. Next slide.
Can you show the next slide? Oh, okay. Thank you. Okay, the flight plan has been designed to be able to perform at 10,000 kilometers.
Excuse me, Alicia, we don't hear you very clear. Could you speak louder, please?
Oh, sorry.
Thank you.
Okay, now the flight plan. Now it's better. Okay, thank you. Has been designed to be able to perform at 10,000 kilometers flight in towards maximum. For this purpose, we have analyzed the different flight phases: ground launch, space, and re-entry phase. The study includes the conditions to which the aircraft will be exposed and the change of speeds, pressures, and temperatures of the aircraft. The airport's requirements for this type of flight are for the runaways, survival radar, system of laser antennas, system of glide slope antennas, and lodging of fuel supply. Okay, can you show the next slide, please? Okay, thank you. This type of flight could be applied to different routes around the world, such as Dubai, New York, Dallas, Sydney, or Los Angeles, Rome. The number of passengers is limited to a maximum of 10. In the next slide, my partner Carlos is going to explain the propulsion system. Thank you.
Okay, ARIC J-72 contains 2 turbojet engines, and this name is due to the combination of the names turbojet and ramjet, because this engine is a mixture of both engines. The turbojet is considered a continuous combustion engine, and the ramjets need to go at high speeds to start working. So the turbo ramjet mixes the properties of both engines, so that the aircraft can take off from a runway on its own at subsonic speeds and gain speed until it reaches supersonic speeds. In the next slide, okay, I'm going to explain the rocket engine. The aircraft also contains a liquid hydrogen and oxygen rocket engine, because that combination produces the highest specific impulse of any known rocket booster. And now André will explain the part of command and control system in the next slide.
For the design of the command and control system, we had 3 main points to take into account. First was the type of plane, second, safety, and third, comfort of passengers. Next slide, please. Starting with the type of plane, our plane is very similar in shape with other hypersonic planes, such as the Concorde. Our plane doesn't have a stabilizer, so every movement except yaw is controlled by the ailerons, which you can see in the image. Depending on the type of maneuver, the outer or inner elements will be used. Also, as you can see in the image, there are multiple actuators controlling the movement of the elements. Next slide, please. So, this is our quadruple redundant fly-by-wire system. In model planes, it is common to see triple or double redundancy fly-by-wire systems. However, our plane will be flying in much harder conditions than any other commercial plane. So in order to increase safety, we decided to make it quadruple. About control of the pilot, flying an aircraft at such speed and altitude as this one requires a lot of skills from the pilot. Also, any minor movement or mistake could cause harm to the plane and passengers or discomfort. That's why we decided that the best way was to implement a restricted control system in which the computer of the aircraft will fly the plane automatically for the majority of the flight, restricting the pilot input. Also, in case of minor failure, the aircraft will continue flying without any changes. However, if any major failure happened that impeded the proper functioning of autopilot, the pilot will be given direct control. And now Irene will explain the part of safety and emergency in the next slide.
Okay. When designing an aircraft, it's very important to ensure the maximum safety of the aircraft. We must assume that there will always be operational failures in flight. Therefore, we must avoid a large number of these by ensuring maximum safety. How can we do this? Next slide, please. For Arrow J72, we have chosen to carry out a fault hazard analysis. For this, priorities have been assigned for the most common failures based on data from previous flights. Next slide, please. After this, we perform the analysis as shown in the following table, in which we see a failure from the propulsion system. Regarding engine operation, for lack of oil or engine icing failure conditions, is classified as a hazardous failure that seriously affects the controllability of the aircraft. Next slide. In order to be prepared for all types of aircraft failures, the emergency system has been designed with the following subsystems. First of all, we have the warning system, which will consist of a color-coded panel on the cockpit for its fault. This is followed by the fire detection system with a temperature control and portable fire extinguishers. The aircraft also has an emergency energy sources in case of total engine shutdown or total shutdown of all systems. Following the line of the engines, how could we avoid a possible engine explosion? Well, for this matter, we have incorporated nitrogen ionization tanks. This will fill the engine vacuum area to avoid a possible explosion. Finally, the aircraft will have a passenger evacuation system with door at ground level and a slide inflation, oxygen mask for the crew, and a crash recorder or well-known black box in case of an accident. The following system will be explained by my partner Ruben.
Hi. As my partner Tirene has said, I'm going to talk about the pneumatic and hydraulic systems. First, we have the pneumatic system that uses the bleed air produced in the engines. In order to reduce the weight of our plane, I've tried that the pneumatic system will be 5,000 psi. In the next slide, we can see our hydraulic system. It's important to say that it's made up of 3 tanks. In this way, in case of some problem, the aircraft will continue operating and it will complete its journey. In addition, I'm going to talk a little bit about our air conditioning and pressurization system, which reduces the air that enters in the cabin to save bleed air. And regarding the electrical system, as you can see in the screen, Alicia is going to talk about it.
Okay, thank you. How have we designed the electrical system? The aircraft is designed to supply 3-phase current of 115 volts and 400 Hz and 28 volts of direct current. The switch from one to the other is done through transformers. The diagram on the slide shows that in order to ensure flight safety, the aircraft will be equipped with a total of 3 main engines that will generate enough power to the aircraft. It is also equipped with an auxiliary power unit and an emergency generator in case of failure. The electrical distribution is therefore so designed that in case of failure, the aircraft can be supplied with enough power to make an emergency landing while maintaining the cabin and the hydraulic system operative. Also in the cockpit, there will be the necessary indicators to check the correct operation of the power supply at all times. In the next slide, my partner Ruben is going to explain the sustainability study we have carried out.
Talking about sustainability, we have designed an eco-friendly plan. This eco-friendly plan is mainly based on the compensation of the carbon footprint of each passenger. This is possible thanks to some measures indicated in our work, like planting of a tree for each person who will use the aircraft. Next slide, please. And well, we have reached the end of the presentation. We hope it has been enjoyable and interesting, and we appreciate your attention. Thanks, Mathieu, for making it possible. I'm sorry for the problems.